Hi everyone, I welcome you to this presentation on Zener voltage regulator. So the use of Zener diode as a regulator is so common that three conditions surrounding the analysis of basic Zener regulator are considered. So a Zener diode looks something like that. So the analysis is first for fixed quantities, followed by fixed supply voltage, where you have the supply voltage which is fixed, and then the load is variable. And finally, the third one is you have a fixed load and the supply is variable. So this answers this. Zener regulators are considered under three conditions. We are going to look at these three. So in this lecture, my focus is on the fixed quantities. So here we are going to have the supply voltage which is fixed and the load, the resistor, which is fixed. Such a circuit looks like that. So you have voltage input which is fixed and the load is fixed like that. Then you are going to have a Zener diode and a resistor there. So from this, you need to determine the state of the Zener diode by first you remove it from the network, and then you calculate the voltage across the resulting open circuit. So when you're given this, remove this Zener diode, and then you determine the state of the Zener diode by that formula. So you calculate the voltage on the load after removing that. Once you calculate the voltage on the load, then there are conditions you need to follow. If V, the one you're calculating, is greater or equal to the value of the Zener diode, because the Zener diode will have a voltage there, then this Zener diode is in the on state. So you replace this with the appropriate equivalent model. If V, the one you calculate, is less than the Zener voltage, then it means the diode is in the off state. You also remove it from the circuit and then you replace it with the open circuit equivalent. You understand this in examples. So for example, for the Zener diode network shown below, determine VL, VR, IZ, and PZ. VL being the voltage at the load, VR the voltage for this resistor, IZ is the Zener current, and PZ is the power on the Zener. So the first step to do in our solution is you need to determine the state of the Zener diode. Is it in the on or the off state? So we are determining the state by remove the Zener from the circuit. Once you remove it, then you calculate the voltage drop across the load there, or across the removed Zener diode, because they're in parallel. So you do that. So the voltage, the V we are calculating, which is the same as the voltage on the load because they are in parallel, is basically voltage divided by rho. You've got two resistors, you've got this one and this one. The voltage drop across this, you're having that. When you replace the parameters, you have that, you're going to have 8.73. So 8.73 as compared to the given value of the Zener diode, you realize that 8.73 is less than 10. So if V is less than the given value for the Zener diode, then this diode is in the off state. If it's in the off state, you remove it from the circuit and then you replace it with the circuit equivalent, which is just an open circuit. So you're going to have a circuit which is a series combination of this resistor and that one. Here there is an open circuit, and then you can calculate these parameters. So the value for VL is the voltage drop across that, which is just the one we've calculated there. You're going to have 8.73 volts. The value for VR, this one here, you can do voltage divided by rho, where this one is the one on the numerator there, or you have this one, it's dropping across that one and that one. Therefore, the voltage drop, or the voltage across R here, it's basically VI minus VL. When you do that subtraction, you're going to have that 7.27. Okay, then you also have IZ, which is the current passing through the Zener diode. As you can see, this is an open circuit, so there is no current passing through there. So the current is 0 amps, and the power passing through the Zener is also 0 because it's an open circuit. So this is for the off-state condition. And then to answer the B part, where they are saying you change now, where there is a load resistor of 1.2, they are saying we use 3 kilo ohms. Okay, so for the B part, we determine the state of the Zener by using that formula. You realize that when you replace that RL with 3, you're going to have 12 volts, and 12 volts as compared to what we had, it is greater. Therefore, this Zener diode is in the on state. So since this one is the on state, you're going to replace the Zener diode with the Zener itself. which are the value of 10 volts. So you are going to have this, and then we can start our analysis from there, where we can calculate the given parameters there. So VL, which is the voltage across the load, will basically be the voltage on the Zener, which is 10 volts because it was given. So this 12 volts is just telling you the state of the Zener. It's not the one you use. You use the one which was given on the Zener. So you have this one there. And then VR, which is the voltage on there, it's basically VI minus the VL there, which is this one there. Then you are going to have 6 volts like that. IL, the current passing through the load, is basically the voltage on the load divided by the resistor there. If you substitute there, you're going to have that one. Then you have IR, which is the current passing through the resistor. It's VR over R. When you do substitutions, you're going to have that. Then you can calculate now the current passing through the Zener as the difference between I, because IZ is basically IR minus IL. You have this one there, which is that value there. Then we can easily calculate the power on the Zener, which is basically the voltage on the Zener times the current on the Zener. Voltage on the Zener, we know it's 10 volts. Current on the Zener is the one we are from calculating there. When you multiply, you're going to have that as your power on the Zener. So this marks the end of this presentation on Zener diode regulator for fixed variables. Thank you so much.